Okay, W5HRO here on, what is this, part 7 now. I did get my new relays in, the mechanical ones. These were cheap ones from China. They're like $15 a piece. I mean, they're 40 amps. I mean, look at them. They're pretty hefty. They should work good enough for now. I was talking to somebody and they said that I should use mercury displacement relays. And I thought, oh, okay, that's probably not a bad idea. And I did order one of those. I ordered like a big 100 amp MDI, normally open relay with a 24 volt coil. But I'm not sure, I mean, I'm not going to use that on this panel. What I'm going to do is, the bottom line is I could probably still get solid state relays to work on this. But whatever I do, it's going to be on a different panel at some other point in time. Because what I want to do, eventually is I'd like to put a couple variacs on the panel, so I could control the plate voltages of each transformer down. I could just control the primary input voltage, and that means a whole new panel. And I want to rearrange things, and I want to add more lights. And this supply was mounted up a little bit too high because I found some heftier switches. They're a little bit longer, so if I use those, this will be up too high, and I'd have to move it down. And so what I'm going to do is I'm just going to use these cheap Chinese mechanical relays for now, just to get the whole transmitter working again. And then when I eventually have time on down the road, I'll either try some 100 amp solid state relays, or I'll use the mercury displacement relays I ordered. I ordered as a dual one that I ordered. It's like a 100 amp 24 volt coil, as I've already stated. And another thing I'm going to add these Amphenol inrush protectors. And I'm going to put one of these on the output of each of these relays to each of the plate transformers, and that should help a bunch. I don't know why I didn't think of that in the first place. Somebody said, yeah, I should use those too, and that's a good idea. These are Amphenol. They're the ones that have 16 amps of steady state current capability. These are the heaviest ones of these they make, so I'm hoping they're big enough. They're the CL101s. They should be. I'll try them and see how it goes. But if I was to use some 100 amp solid state relays on the heat sinks, and I put one of these in series on each side of the relay, like just use two of them total, I could probably get away with using 100 amp solid state relays. But what I'll do is I'm going to try the mercury displacement relays. I'll just mount everything on a separate piece of plywood, and I'll build it up, and I'll just experiment, and I'll figure out a way when I have time someday. I'll hook it up to the transmitter in there, and I'll just disconnect this and just put the new thing in its place, and I'm experimenting with, and I'll see how it goes. One of the things I want to do too is the mercury displacement relay, the coils with both of them in parallel, it's like what, 32 ohms or something? I mean, it's like almost an amp of current draw, just under it. And this one here, see, I got lucky on this. I measured both of these relays. Each of these together, each one of these is just under 70 ohms. Both of these in parallel, the coils are like about 32 ohms. It's the same, but it's 12 volts. And that comes up to just under a half an amp, right? Well, it's like 0.3 some odd, what is it? 100 some odd milliamps. Well, this is what? This is one of those Radio Shack. This is one of those 0.4. Yeah, this is one of those 450 milliamp transformers. So this supply is just big enough to turn these relays on. And it's a 12 volt, each side, and then you got a center tap. So with the center tap grounded like it is, you got 12.6 volts, and you're going to have a lot of capacitor bleed until you engage the coils. So I'll have to see where it is on the after the coils are latched on both of them to see what the voltage is, and I may have to adjust this a little bit to get it down. I don't want it any higher than 12 volts. I want the coils to stay nice and cool. They're probably 12.6 volt coils, but getting them right at 12 would probably be better. But they're pretty decent relays. I mean, you can't beat these things. I mean, look, they're heavy suckers. For $15 a piece, it's the cheapest thing I could do just to get this thing going for now. chances are a lot of times I'll do something like this and it keeps, it works fine and it just keeps working and then it becomes a permanent fixture. But I'm probably going to redo it because I would like to mount. I found some small variacs that I can mount on each side and rearrange everything with some other relays. And then, the mercury displacement relays or the solid state relays, either one. I'll try both and see which one I like better. But, what I was going to say was, if I use the mercury displacement relay, that's almost an amp of current draw that engage both of the single pole ones because it's a dual. And that's what I'm trying to do is I'm trying to reduce the wattage the transmitter draws. And since I've converted it to 120 volts, AC instead of 240, it's it's going to draw a lot more line current. And, watts are still watts, but I'm like, I'd like to get the power dissipation down. And to build a supply like this, I already took this off, that's why everything's loose, but to build a supply like this to be able to power up that mercury displacement relay dual one that I've got coming, it's going to take a lot bigger transformer. And I'm like, that's just more watts, right? It's more watts. So I'm like, okay. Well, those cheap ones they sell on eBay or Amazon, the ones that come from China, those little boards, those switching supplies. I ordered a couple of those. I found they're like dirt cheap. They're like $8 a piece, so I ordered 2 of them. And they're 24 volts, like 4 to 6 amps output. I thought, well, they're smaller than this guy is. And I thought, all I've got to do is mount it in a little shielded box and mount it on a new panel. Then I've got 24 volts and it's a switching supply. So, I mean, it doesn't draw a lot of watts from your AC line. So it's a lot more efficient. And that's kind of what I'm shooting for. So I just want to show you this. I just got these relays in yesterday afternoon, kind of late. And you know what I'm out of? I've got everything I need, except I don't have any more cable ties. I've got cable ties coming. Right now all the stores are closed because of this stupid Kung Flu virus. So, you can't go to Home Depot and grab this stuff, or Osh is gone. They used to have all the GC electronic brands of the cable ties hanging in the packs on the rack. But, so you have to order them online. And of course I have to wait several days or a week for them to get here. And they're supposed to be here Thursday or Friday. And this is what, Tuesday? So I've still got another day or two before they're going to get here, a couple days at least. So that's what I'm waiting on. I'm out of cable ties. But I'm going to go ahead and start on this, and I guess I can cable tie it afterwards. But I'm going to work on this later today. And let's go in the shack and I'll show you what... This is more or less an update video. I'm waiting on... When that door squeak is loud. I'm waiting on parts, so I can't really do much more except just do some minor things here until I get the cable ties in and stuff. But I did go through all this yesterday. And I wired up the primaries, the plate transformers. I created all new nice short jumpers. I went ahead and I'm going to redo all the wiring on that panel out in the garage I just showed you again too, because I'm gonna get rid of the red wires. I'm gonna make everything black and white so everything's color coded like it should be. And see, I've got everything wired down there. One goes to the other one side, and the other black goes to the other side. The neutral, of course, is common. But what I did was I did check the phasing of these transformers. That was important. And I had the scope hooked up yesterday. And what I did was I just got my B&K sine wave generator out, and I just inputted an AC signal into the secondary. I went like from this one to to there. And I checked everything, and sure enough, the phasing, everything was numbered. When the guys wound these transformers for me back in the late 80s, early 90s, they pulled the right wire up from the windings to the right terminal. So everything was correct. Because I looked at it, and when I hooked it up, and I put channel 1 on the secondary where I had the generator going in, and I used that to trigger on, and I just put this channel 2 on the outputs. And when I put the input signal here, like say to pin 2, it was out of phase at pin 4 and out of phase at pin 2, so that told me these are all in the right phase, and it was the same way on both transformers. And I even went ahead and I ran the generator output up as high as I could get it into the diodes to make sure they would still conduct. And I went out in the garage and I grabbed the electrolytic cap and put across the voltmeter leads, the scope leads, so I could see, make sure. And it was coming up DC when I got up high enough. Of course, if I shove, 2-some-odd thousand volts in those, one of them could be bad. I don't think they're bad, but I went with a low voltage to make sure they didn't somehow, they didn't get shorted or anything, and they're still conducting and they're rectifying the AC, so it's working. So I've got that all ready, and what I'm going to do here in a little while too, I'm actually going to do this first. I'm going to take these two cables off, and I'm going to redo it now since I've got these terminals. And I'm going to go ahead and I'm going to get this base put back in here today. Then after I get that done, I'm going to go out there and I'm going to work on the panel and put those relays on there, the ones I just got. But I want to go over too, this is the modulator deck. And I'm going to go into this more in detail when I have time, but this right here, this is all Peter Dahl transformers, right? This is that custom desk kilowatt transformer that's tweak wound for my tube and my voltages and my plate transformers. It's the desk KW transformer, Collins KWS1. It's just tweaked for the ratio, the little bit off that I needed. So I'd have the exact ratio. And there's the, what is that? Is that the filament transformer? I can't see through my phone. 10 volt. Yeah, that's the filament transformer for the 810s. And then there's that's the desk KW bias transformer. That's for the grid voltage. That's the grid bias transformer. And then here's that KWS1 or KW1 driver transformer. This couples like the 6A3s or the 2A3s to the 810 grids. Now, there's an issue about this. This is the closest transformer that you'll ever find that'll work with 2A3s or 6A3s or 6B4Gs driving 810s, unless you can find one that's got the quad output, which is ideal. But there's a trick. I found an article in CQ magazine that a guy came up with back in 1955, where he used 6AS7s, which are also low mu triodes, but they're dual and they have separate cathodes. They're not direct heated. So they're a little bit more functional, and they used them as regulators. Well, there's a guy that came up with a circuit which you just basically eliminate this transformer. You pop in a 6AS7G tube, which is a dual triode, and it's a cathode follower connection to the tubes. And basically, the reason 810s are like the worst case scenario for audio tubes needing to be driven in a modulator. They're like the worst case. It requires more drive power than necessary because of the way they behave. Because, from static bias to full modulated bias, the current goes from one extreme to the other. And this is the old 2-to-1 step-down transformer. It's like my 6A3s are running cathode bias, so the thing is like what? They're like 5,000 ohms to 2,500 ohms or 22, whatever it is. It's a step down's what it is. It's like about a 2-to-1 step down, pretty close to it. And but the problem is the ratio of that is for that transformer is okay, from one current standpoint, from like either from one extreme or the other. But when you go from one to the other, the ratio you need really changes, and this is not the exact ratio. I mean, the ratio, because the way 810s behave, because they draw so much current, the grids draw so much current when you're when you're modulating at their full peak to peak potential in class B, they draw a lot of current. So the transformer, the ratio that you really need is not really what this is. It's okay for the basic configuration, basic static configuration, when you just power everything up and you start modulating your static resting current, it's fine. But when you go to that peak, you're going from one extreme, that current's going bang, 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 back and forth. It's hard for that transformer to compensate. It does a pretty good job, but it's not the ideal situation. And the whole point of the reason that 810s need so much drive, like say a quad of 2A3s or 6A3s or 6B4Gs, is because of that very reason. You're going from one extreme to the other in that extreme condition. It takes a lot to get full power out of these things, simply because the peak to peak driving voltage, the signal going into the grids, it decreases too much. So it takes a lot of current to get it there. So that's why you need 4 tubes. But if you use a 6AS7 tube, in cathode configuration, you can just use a pair of you can just use a 6N7 or a 6J5 or two of them in push-pull to drive the 6A-S7 grids. And all you need is one special little transformer, which I do have. This happens to be, this is either a 2-to-1 or it's a 1-to-1. It'll do single-ended to push-pull, or it'll do the push, or it'll do push-pull to push-pull 1-to-1. But it's got, the secondary has 4 different windings. This will actually, you can actually take a 6J5 or a 6SN7 and push-pull, or a 6N7 and push-pull, and drive, 4 2A3s. But the thing is, if you run the secondary into the grids of a 6S or a 6AS7, I always get the number mixed around. It's a 6AS7 twin triode. If you drive this into one of those, then it's problem solved. That is the exact transformer you need to do it. So what I'm eventually going to do is I'm going to try at some point in time. Here's the speech amp driver. There's the 6A3s right there. This is the one that sits up horizontal. I mean, it mounts, I don't mean horizontal, it sits vertically inside the cabinet, right? Because it's mounted flush to the back panel. And what I have is, I have a 6SJ7 GT going to the 6N7 phase inverter, and that drives the 6A3s. Well, when I had this thing apart years ago, after I moved the transmitter to San Jose in our old house, and I had it out in the garage, and I did hook up a 6SN7 on a separate little chassis, and I had everything hardwired. I was playing around with it, had the scope hooked up there for a few weeks, and I need to put a 6S K7, compression, extra drive tube in them. So what I'm going to do is, I've got the 6SJ7 here, and I'm going to take that tube out. I'm going to rewire it for the 6SK7, and then I'm going to take this tube out, drill a hole, move it down here. So I've got both of these driver tubes this way, and then in this socket, I'm going to change the socket, and I'm going to put the 6N7 there, or I'm going to convert it to a 6SN7, one of the two. But I'm going to modify that temporarily. But what I'm eventually going to probably do is, I want to see if I can eliminate this transformer and do the 6AS7G conversion, because that's the ideal solution. I think it'll work like gangbusters. And then what I can do is, I'm going to build up another, probably another speech amp driver rack. I don't like the way I laid this thing out. A couple of these things, the way this is laid out was an afterthought. This is the, 5Y3 rectifier tube. I should have mounted the choke over here and the supply components. When I laid this out, it was the way I eventually was going to put it. It was going to be mounted horizontal, and I realized when my cabinet layout, I needed to make this a vertical panel. And some of the old Collins transmitters in the old days, they used to have the speech amp and the driver, rack mounted vertically. So that's where I got the idea from, because it saved me a lot of space. Otherwise, I would have needed a taller cabinet, and that was the tallest one Bud made at the time, or they still make. So that's how I solved the problem. I used the old Collins design, and I mounted it in there vertically, which is great anyway, because the underneath part of the chassis is all shielded because it's mounted flush to the aluminum front panel on the back side. It's perfect. So what I'll do is, I'll build up another one of those, and I may put the 6A3 there, and I'll just run the wires down where I can just bypass this transformer. The input jacks here, I'll just rewire the connections. Instead of going to the transformer, I'll just move them to the grids, and I'll play around with it that way. I'll experiment, but I'll keep this old one after I modify it here, which I'm going to do here soon. I'm just going to add that other tube in there and move that 6A3 down to the other side. But I'll just leave that like it is when I get that done, and I'll just build another one to experiment with, so I still have this one just in case it doesn't work. I think it will, though. I think it really will. But one of the things too one of my main concerns is, this whole rack is going away. This whole bias supply rack. See how many rectifier tubes I have on there, how many filaments I got going. I mean, This transmitter draws a lot of watts, and now that I've switched it over to 110 or the 120 instead of 240, I'm thinking, should I solid state out? Like, here's a 5R4, that 5Y3. I'm thinking I should just build up some solid state modules and plug in there to reduce the wattage consumption of this transmitter. I built this, when I originally built this, I was dead set on I'm not using any solid state components except for the solid state relays to turn on the plate transformers, because I hate that mechanical click. Those Chinese ones I got are probably going to go snap. They probably shouldn't be too loud. I could mount some rubber stoppers, some thick rubber washers underneath maybe to minimize the vibration, because I don't like to hear a click when you transmit. I don't want to hear it. It's just, I like a quiet, simple, plus the solid state relays are so fast, everything turns on me within instantly. So I'm looking for fast turn on as well. But when I built this thing, I said, no solid state. Everything's going to be the old fashioned way. Everything's going to be tubes. But, now that I've converted this thing to 120, it's, like I said, watts are still watts. It's still going to be the same in the end, but it's just, I know when I transmit, the lights here in the shack are probably going to dim a little bit. So anything I can do to lessen the load on the wall outlet's going to help. And I'm thinking, should I switch this thing over? I don't know. I could just plug in the replacements to take the load off it would eliminate because this one driver transformer, I don't mean driver, this bias supply transformer has got the winding in it for the 6A3, or does it? You know what? I don't know. Is that a choke? I think I did choke input on this. There's a electrolytic cap I know on the bottom side. I'll have to turn this thing over and look at it when I get done. When I get ready for it, I mean. And there's the bias. Here's the knob. It's on a potentiometer. There's a big rheostat underneath where I adjust the grid bias. It's like minus 55 volts, somewhere abouts there, to get you, because what you want is you want 60 mils of static bias on the 810 tubes. But when I get a chance, I'll post the diagram I found to replace this thing with a 6AS7G tube. And I just don't have time right now. I want to get this stuff going. I want to get this thing all put back together so I can start powering the thing up and get the plate transformers to come up. And when I do that, then I'm going to start sliding in these other racks, and I'm going to go through and clean this thing up good. I'm going to turn it over and debate whether I want to go ahead and remove this tube and put in a solid state replacement. I might do that. I mean, what's it going to hurt, right? It's just going to take less. It's going to make the electric bill a little bit lighter, right? It'll be a little bit less every month, maybe by a few cents. So that's where I am. Right now I'm waiting on cable ties and the rest of I've got all my parts. I don't need the mercury relays yet, because I'm not going to do that. It's going to be a project on down the road. Oh, but what's happened is a lot of the states are banning the sale of products with mercury in them. California, they have banned the sale of some things, but guess what? You can still get the mercury relays here in California, but that may change. That's why I went ahead and I grabbed one of them now. But as soon as I get this thing slid back in there and I get that new panel out in the garage with me, and the new relays on that panel I'm rebuilding out in the garage, and I get it put back up here. As soon as I get the thing powered up here and I get the filter rack in here and I get the thing where the voltage comes up when I transmit, I'll show you. I'll make another video. So that's all I have for right now. This is W5HRO.